Above the entrance to the Platonic Academy at Athens, we are told, was an inscription which read, "Let no one ignorant of geometry enter here." The plane of this ancient geometry was conceived of as a void, as something which had the potential to receive existence only by the act of generation. It begins, then, with a single point. Only two instruments exist for the constructions of Euclidean geometry. The first is the straight edge, which allows the line to come into existence. The second is the compass, which brings the circle into existence by the act of rotation and joins the source to the perimeter. We will refer to this simple construction as the cosmic icon. This icon represents the cosmos as proceeding from God as the source and center of creation, expanding across an intermediary domain to the corporeal world in which we live our lives. Beyond that lies the chaos of outer darkness. Where then do the particles and fields of physics enter the picture? Where do these entities fit into the cosmic icon? And how, in the end, do we get from these particles and fields to the world in which we live and move and have our being?
The builders keep on building. The tearers down keep tearing down. Killers keep on killing, and the dead keep coming around. In the words of Albert Einstein, there is no solid ground to build on, but the builders keep on building, looking down, 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 one way. One way up.
I want to tell you how I met Wolfgang Smith and how he has changed my life.
I hold him in very high esteem. In fact, among European Western thinkers, a man who combines a knowledge of modern science to this level, as well as traditional metaphysics and spirituality, and add to that specific Catholic theology and early Catholic philosophy, is very rare. Probably there's no one like him.
One way up, one way up, way up, one way up.
When they say this, sometimes there's a limit. Oh, maybe science has its limitations. They don't know what they're talking about, because science is limitations. Without limitations, there is no science. Eddington said, you think this is a table, but in fact it's a bunch of particles. They say, well, we can invert this. See this bunch of particles? You think it's a bunch of particles, but in fact it's a table.
One way up, way up, one way up, one way up, way up, one way up.
It's not just in physics, it's in everything. Everything is conspiring to what the physicists would call a singularity, where things just break down and they can't go on the way they have been going on.
One way up, way up. One way up, way up. One way up, way up. One way up.
We all knew it was coming. Every pillar was wobbling at once. Political, financial, religious, military, and of course, scientific.
We are approaching a very singular moment in history. That doesn't happen often.
Looking back, it is as if we were hypnotized, and we were.
No one understands quantum theory.
In 1985, in a book entitled Quantum Reality, a physicist by the name of Nick Herbert revealed a startling fact. One of the best-kept secrets of science, he writes, is that physicists have lost their grip on reality. Unbeknownst to the general public, there has been for the past century an ongoing quest among top-ranking physicists to determine what precisely the findings of quantum theory entail regarding the nature of the physical universe. A multitude of competing theories have been advanced, which strike the uninitiated as ranging from the more or less weird to the patently absurd. The classic notion that the universe is made of atomic particles, which goes back all the way to Democritus, has proved to be untenable, which is to say, physicists really have lost their grip on reality. The great arc of human history over the past 4 centuries has been characterized by a stupendous project to reduce the world to quantity. Quantum physics, our foundational science, would reduce the world to quantum particles. Evolutionary biology would reduce living organisms to aggregates of such particles, resulting from random, stochastic, and deterministic processes. Whilst post-Einsteinian cosmology would reduce the cosmos itself to random fluctuations in the quantum vacuum. The reign of quantity is reaching its full measure, which turns out also to be its reductio ad absurdum. It is time to take stock of what has befallen us. Time to break the spell. Wolfgang Smith was born in 1930 in Vienna. Graduating from Cornell University with majors in physics, mathematics, and philosophy at age 18, he obtained his master's degree in theoretical physics at Purdue University before moving on to help lay the foundations for the re-entry problem during his work as an aerodynamicist at Bell Aircraft Corporation. After obtaining his PhD in mathematics from Columbia University, Smith held faculty positions at MIT, UCLA, and Oregon State University. He's well known in traditionalist circles through his books, including Cosmos and Transcendence, Teilhardism and the New Religion, and The Quantum Enigma. His unique background as mathematician, physicist, and philosopher, and crucially, his outsider status with regard to any establishment of our time, provides the vantage point from which Wolfgang Smith is able to identify what turns out to be the Achilles heel of the present scientific worldview.
Mathematical physics received its first definitive formulation in 1687 with the publication of Sir Isaac Newton's Principia. And from the outset, it was tacitly assumed that material objects were made of minute, indecomposable entities termed atoms. It was moreover understood that these were too small by far to be detected by means then at the disposal of the experimentalist, yet the expectation was rife that in time the discovery would be made.
In 1897, the anticipated breakthrough was in fact achieved by physicist J.J. Thomson in his discovery of the electron. The catch, however, is that it turns out not to be a Newtonian atom, that is to say, an authentic particle, but a so-called quantum particle, which is, in truth, not a particle at all.
One source of so-called quantum paradox was the so-called superposition principle, the fact, namely, that states of a physical system could be added, which means, for example, that a single particle could, in a sense, multilocate, could be in any number of regions at once, inasmuch as an observed or actual particle obviously does not thus multilocate. A radical discrepancy between the observed and the unobserved physical universe came into view.
The senior quantum theorist, Niels Bohr, responded to the impasse by affirming soberly, "There is no quantum reality. There is only a quantum description." What, however, rendered this position less than satisfying is the fact that it had by now become clear that there is no classical reality as well. The time-honored notion of atoms as indecomposable bits of matter had by now proved to be chimerical.
What then is the quantum enigma? It resides in the fact that there are no actual particles in the quantum world. That actual particles come into existence abruptly in the act of observation or measurement. So, what is there before measurement? Not a thing.
The concept of substance has disappeared from fundamental physics.
It thus became apparent that the act of observation or measurement has a profound and inherently unpredictable impact upon the physical system itself, an undeniable fact which physicists could not explain, and which, moreover, gave rise to unending speculations on the part of a philosophically interested minority, which, however, includes some of the most illustrious names, beginning with the famous Bohr-Einstein debate in 1927.
It is hardly surprising that some quantum theorists have proposed that ordinary logic does not apply in the quantum domain. What is needed, they say, is a quantum logic.
Another strategy to rid the world of quantum paradox, proposed by a cadre of intrepid theorists, is to stipulate that every measurement of quantum particles splits the universe into as many copies of itself as there are possible outcomes, a notion that marks the birth of so-called multiverse theory.
Ah, there is that word again. Multiverse. Well, it is true that the means by which the multiverse of the cosmologists is generated is entirely different than the many worlds interpretation of quantum physics, first proposed by Hugh Everett and often associated with his thesis supervisor John Wheeler. When one looks carefully, one can see that it is the same solution to the problem. The multiverse, on both the large and small ends of the scale, constitutes an appeal to an infinity of worlds we cannot observe in order to explain the one that we can.
For close to a century thus, the quantum reality problem has spawned a plethora of proposed solutions which seem to have only one thing in common. Each strikes the non-specialist as quite absurd, some more, admittedly, and some less.
For the first time in human history, it appears, civilization has succumbed to a worldview based on a science which, in the words of Richard Feynman, no one understands. And what is even more remarkable is that this too, apparently, is a fact which no one understands.
We have abolished the true world What has remained? The apparent one, perhaps? Oh, no. With the true world, we have also abolished the apparent one.
By the time the quantum reality debate had passed the half-century mark without a semblance even of a resolution in sight, it became apparent that something was seriously amiss. It was at this point that Wolfgang Smith became interested in this fateful conundrum.
It was in the 90s, after I had for some time perused this curious literature, that I was struck by what proved to be a decisive recognition. It became evident to me that all these quantum reality theorists, unbeknownst to themselves, had assumed the highly dubious premises of René Descartes. The supposition, namely, that the real splits neatly into two disjoint domains, an external world consisting of so-called res extensae, or extended entities, and an internal or subjective domain pertaining to so-called res cogitantes, or thinking entities. I felt that I had discovered the source of the difficulty, the hidden premise which has all along bedeviled the quantum reality debate. It doesn't mean that the physicists are conscious of that. I mean, many of them perhaps have not even heard of René Descartes, but unconsciously they have, and I would almost say to a man, absorbed that philosophy. What is characteristic of the external domain and in a way defines it is that it is populated with objects which can be described completely without residue in mathematical terms. So therefore, everything which pertains to the realm of qualities had to be eliminated from the external world. He relegated these qualitative parameters to a subjective world, which he referred to as a world of res cogitantes, thinking entities. So, as it were by force, he eliminated the qualities, he pushed them over out of the way, so to speak, in order to produce a world which would be ideal for the mathematical physicists. And this is what enables them to take a corporeal object, a piece of stone or a piece of organic tissue or whatever it may be, and say, this is nothing but quantum particles. They could not say that if they did not assume that the qualities, for example, the color red, is subjective.
With the qualities thus banished to the realm of the mind, the way was open for the establishment of the age of the reign of quantity, when equations could describe everything from the orbit of the planets to the fall of a feather. A almost clockwork conception of a universe of cause and effect.
The Newtonian or clockwork universe paradigm is based upon the notion of bare matter, the parts of which interact through forces of attraction or repulsion, so that the movement of the whole is determined by the disposition of the parts.
To be sure, the concept of bare matter, of a Cartesian res extensa, turns out to be philosophically problematic and ultimately untenable in light of the discovery of the quantum domain, of the physical universe. Despite its philosophical invalidity, the success of the Newtonian paradigm has proved to be spectacular. From the publication of Newton's Principia in 1687 to the 20th century, this conception was looked upon not merely as a way of knowing, but as the master key to unlock all of reality.
even fallacious premises can play a legitimate role as a paradigm, especially in the early stages of an evolving science, where oversimplification, so far from being an impediment, constitutes a prime necessity. One can see in retrospect that Newtonian physics needed the drastic oversimplification implicit in its paradigm to lift off the ground, that in fact even an inkling of the so-called quantum world would have had a paralyzing and indeed fatal impact upon its further development. By the same token, however, it needs to be recognized that paradigms can indeed outlive their usefulness and turn into an insurmountable barrier to the further development of a science.
In the first 2 decades of the 20th century, experiments began to raise serious problems for the Newtonian conception of physical reality. It has long been known, for example, that black bodies made to glow, for instance, in furnaces, having no color of their own, ought to glow blue, according to Newtonian classical physics. However, as any steel worker knows, they glow cherry red at temperatures of around 1300 degrees Fahrenheit. The deviation from predicted behavior attracted the attention of a hitherto unknown physicist named Max Planck in 1900.
Planck decided to calculate the emitted energy E of vibrating particles as multiples of h nu, where nu is the frequency of the emitted radiation and h is a constant to be determined. When h was allowed to go to 0, Planck obtained the classical result. The black body ought to glow blue. However, if h was assigned one particular value, the calculation would match observations perfectly. Thus, Planck showed that furnaces glow red only if the emitted energy of particles satisfies this hitherto unknown formula. What finally stands at issue in the black body problem is to connect the frequency of an emitted wave to the energy of a vibrating particle. And what is needed, basically, is a bridge from a particle to a wave description of physical reality.
Since then, the constant h has turned up again and again as the bridge between the physical universe conceived of as particles and the physical universe conceived of as waves.
The implications of this recognition turn out to be world-shattering. The worldview of classical physics has been broken irretrievably.
This was recognized by an almost forlorn-sounding Albert Einstein. All my attempts to adapt the theoretical foundations of physics to these new notions failed completely. It was as if the ground had been pulled out from under one, with no firm foundation to be seen anywhere upon which one could have built. In the experiments about atomic events, we have to do with things and facts, with phenomena that are just as real as any phenomena of daily life. But the atoms or the elementary particles themselves are not as real. They form a world of potentialities or possibilities rather than one of things and facts.
It was Werner Heisenberg who evinced the deepest insight into the enigma of quantum reality. What Heisenberg tells us about quantum particles proves to be as enlightening as it is enigmatic. Quantum particles are something, quote, midway between being and non-being, and as such are reminiscent of Aristotelian potentiae. Thus, having replaced the corporeal world by the physical, physicists discovered that the physical does not actually exist. As Lord Kelvin had recognized long ago, the defining fact concerning physics at large is that it proves to be none other than the science of measurement. Now, in keeping with this basic recognition, Heisenberg realized that it is needful to jettison the classical Newtonian description of physical systems and replace it by a mathematical formalism the world had never yet seen.
The breakthrough came in July of 1925, when a 24-year-old Heisenberg found himself alone on the bleak North Sea island of Helgoland, where he had gone for reasons of health.
He is the one who really broke through and developed this brand new physics. In light of this basic recognition, he postulated that what exists in general prior to measurement are not the actual values of an observable, but only their probabilities. Moreover, by a stroke of genius, he perceived that these probabilities could be represented in terms of a square array of numbers termed a matrix, and thus was born a brand new formalism for quantum theory known as matrix mechanics, which breaks radically with the classical.
We return now to our cosmic icon and situate this newly discovered quantum world of potentiae at the boundary between our corporeal world and the outer darkness. It is measurement that effects the transition from potency to act, from the chaos of multi-locating particles to the world of corporeal being. With smiling certainty, he once said to me, I was lucky enough to be allowed once to look over the good Lord's shoulder while he was at work. That was enough for him, and more than enough.
Most importantly, the new theory worked like a charm. Since then, it has been in use for over 90 years, and in thousands of experiments has never yet failed. By all counts, it is the most accurate mathematical physics ever conceived by man.
These quantum mechanical calculations typically attain levels of accuracy unheard of in pre-quantum days, reflecting the fact that, notwithstanding our inability to comprehend in non-mathematical terms what is going on, we are dealing no longer with macroscopic approximations, but with mathematical structures on a foundational plane.
But since these structures consist exclusively in quantities, they cannot bring us into the world where we perceive qualities, green grass and red apples and the songs of birds.
Qualities pertain to essence, and thus to being, no less. The fact is that nothing bereft of qualities can actually exist, which is precisely the reason why the physical universe proves to be sub-existential, a domain made up of mere potentiae.
Heisenberg realized that the quantum world, while certainly more than merely a description, still falls short of being an actual world in which we live and move and have our being. And still, he struggled to the end of his life to understand exactly what this relationship might be.
Why, for example, an actual cat cannot be both dead and alive.
Heisenberg appears to have come within a hair's breadth of resolving the quantum enigma. But in the end, it appears to have eluded his grasp. The question is, why?
The prime example of a scientific belief is doubtless the well-nigh universally accepted notion that corporeal objects are made of fundamental particles. What confronts us here is a residual Cartesianism, unconsciously presupposed within the scientific community and thence passed on to the public at large by way of schools and universities and of late the media.
The universally accepted notion that corporeal objects are made of fundamental particles. Here's the crucial assumption that may explain why Heisenberg failed to go all the way in resolving the quantum enigma.
It's like breaking through a fortified wall, and then you can go all the rest of the way, there's nothing there, and suddenly you stop. He arrived at the position that although a single quantum particle is mere potency, when you have enough of them, like 10 to the power 36, then you are in act. As if the mere aggregation of potencies can put you into the real world.
After all, how can a mere aggregation of potentiae, howsoever many potentiae you care to lump together, somehow become a thing, a chair upon which we can sit, or a tree under which we can take shade? There is something more involved, and that something more is tantamount to what the Platonists term essence, and Thomistic philosophy knows as substantial form. Smith's grounding in traditional philosophy, coupled with his hard-won ability to transcend the zeitgeist of contemporary civilization, enabled him to unlock the quantum paradoxes in a way no one has been able to do before. The story begins surprisingly when he was 14 years of age.
Well, in a word, I started to think. Before that age, I had various interests and passed through various phases, of course, but thinking in the true sense of the word started, I would say, almost abruptly at the age of 14. I remember it was quite exasperating for my mother because very often I would be in my room and she would call me to dinner, and I said, I can't come now, I'm thinking.
By the time Wolfgang Smith applied to Cornell University at age 15, his newly discovered propensity for thinking had pointed him in a very specific direction.
On this application form, we were asked what we wanted to major in, and I said physics. And then the question was, why? Why did you choose that major? And I remember to this day my response. I wrote down, I want to study physics because I believe that physics is the key to the understanding of the universe. Needless to say, I've changed my mind in the interim.
During his time at Cornell University, Wolfgang Smith encountered the Gitanjali of Indian poet Rabindranath Tagore, an encounter which changed the future course of his life.
Some of these lines that I read in Gitanjali are still in my head, and I will tell you one of these lines just to give you a little bit the flavor. He says, drunk with the joy of singing, I call you friend, who art my Lord. That struck a chord. I mean, I had never encountered anything like that. And it just touched me deeply. And from that moment on, I realized that there is a mysticism, there are ways of entering into higher, more spiritual realms, which are wonderful and in fundamentally far greater, far more wonderful than what we have here with our ordinary five senses. So I was in a way converted to something at that point. And so philosophy became to me at that point a kind of a holy quest. I understood it literally as philosophia, love of wisdom. So there's wisdom, and this is not just mental acrobatics, this is something mystical, spiritual, and there is love. It's not just an academic occupation. So I studied mathematics, I studied physics, and I studied philosophy, but my heart was in philosophy. From that point, not for a second anymore could I regard physics as the key to the secrets of the universe.
Upon graduation, Smith was accepted into Cornell's graduate school at age 18 for a fellowship in philosophy, but the fellowship proved short-lived indeed.
After 3 weeks, I couldn't stand it. I couldn't stand the milieu. And I went to the chairman of the philosophy department and saying, I'm giving up my fellowship, I'm going away. Because to me, philosophy was philosophia. And these people, were not a bit interested in Sophia, nor was there any philos, any love in their heart at all. It was professionalism, it was cold, it was dry, it was all up here. And I felt not only that I'm not interested in that, I felt it was a profanation of something that is fundamentally sacred. I felt like shaking the dust off my feet.
While harboring a romantic notion of perhaps heading to the Pacific Northwest and working as a lumberjack, Wolfgang soon found out that his older brother, Jerry, had other ideas.
There are times in one's life when the hand of providence enters. And when that happens, you can recognize it. There's no question about it. So what happened is I sent a letter to my brother who was studying at Purdue University, telling him of my intention. He immediately went to the chairman of the physics department at Purdue and told him that I have his brother, he's smart, but he's a little crazy. Please read this letter. And the chairman read it. When it was finished, he said, tell your brother I want to see him here in my office Monday morning. He must start his duties as a teaching assistant in the department.
And just like that, the world lost a lumberjack, but gained a mathematical physicist. Smith ultimately chose to focus on mathematics, obtaining his doctorate from Columbia University. After a 1.5-year fellowship at MIT, he accepted a position on the mathematics faculty at UCLA beginning the next academic year. In the meantime, he took the opportunity to fulfill a dream.
I went to India and the Himalayan regions then for 7 months. And I can really say in retrospect, this was an absolutely decisive event in my life. It turned out very differently from what I had imagined. I imagined that I would climb this ladder, this Jacob's ladder. I did not. However, I sat at the feet of those who had, and I caught a glimpse of their magnificence. I approached these great people and the whole tradition, I approached it with reverence. As I like to say, I approached it with folded hands, and it was just natural to me. And this is, I believe, why I didn't go away empty-handed. While I was traveling in India, there was one question I had, and a question which intrigued me very much, and I posed it to practically all the great saints or sadhus that I met. And it was this. I wanted to know about that supreme state, by whatever name you want to call it. And I wanted to know whether anything of the human is left. Is there anything of this man that survives that ascent and actually is taken up into this supreme state? And the answer which I got invariably is no. The state of affairs reminded me of that famous poem by Edwin Arnold, which speaks of the dewdrop slipping into the shining sea. Now, when that happens, there's nothing left of the dewdrop. The sea gets no bigger, and the dewdrop disappears. Now, there was something in this that I could not really accept. It intrigued me, and I was not satisfied.
Smith returned from India and took up his career as a professor of mathematics, first at UCLA and finally at Oregon State University. But he returned a changed man.
Coming back, I was no longer a Western man in the contemporary sense. There's an outer life as a professor of mathematics, and then there's an inner life as somebody who wants to, as best he can, deepen his understanding of the great metaphysical traditions of the world.
So, Wolfgang Smith seemed prepared to spend the rest of his years in his secluded home in the beautiful forests of Oregon, deeply influenced, but ultimately unsatisfied by the knowledge imparted to him in India. And that's where Thea comes in.
He was a lonely man, a man sent from above. He was a
Something very momentous happened. A beautiful young woman came into the mathematics department to get her PhD in mathematics. And we became acquainted. And by the time she left, after getting her doctorate and was about ready to begin a very fine career at the University of San Diego, I decided I would like to marry her. I proposed, and she accepted, and thus starts a very brand new life. Thea was a deep, deep Catholic. She was deeply rooted in her Catholic faith. It was in her blood and in her bones. And when we were married, I had been raised as a Catholic, but I had drifted away, and I was now in a different kind of spiritual world. And Thea never forced anything on me. Unbeknownst to myself, she, in company with a very wonderful Franciscan monk, Father Giovanni, they were praying daily that I would return to the faith. And so then it happened. I had been reading St. Augustine's commentary on the Gospel of St. John and the biography of St. Catherine of Siena. These two books converted me. So I returned to my Catholic faith. And incidentally, it soon became clear to me that now this nagging question which I asked all over India and which was never answered to my satisfaction, now it was answered. Because Christianity is the religion of the incarnation. God became man so that man could become God, as the fathers have said. So that means that by way of the incarnation, our humanity does not need to be disintegrated, dissolved like the dewdrop, but it can be deified, deificatio. This is the term the fathers have used.
And there is yet one additional momentous thing for which we have to thank Thea.
It was precisely at that point that my life started to become productive. During my Hindu days, if I may put it so, I had no interest in writing. It made no sense to me to write. Why should you write? Well, as soon as I returned to my Catholic roots, I became interested to write. And in all this process, I recognize now more clearly than ever, Thea was there. She was, in a sense, my inspiration, and I can really say my strength. It's a hard thing to explain. She was a powerful spirit, and I, as it were, leaned upon her. So she really is very much a part of this adventure, and I am very happy that my first book and my last are both dedicated to her.
Such was Wolfgang's background and formation when he approached the quantum reality quandary some 20 years ago, having realized from his study of Platonism and the metaphysical traditions of the world that the universe comprises not just quantities, but qualities as well, and having come to understand, moreover, that qualities have primacy, that in fact they resemble a light from higher spheres shining into this world.
The starting point of his reflections could be none other than a critique of the Cartesian bifurcation.
The educated strata of our society have been condemned to a chronic state of schizophrenia. This is schizophrenia. One moment the grass is green, the next moment it is not. That's exactly what schizophrenia is. So that is not a healthy condition, and I realized it and I wrote about it. So once we had corrected all these errors based upon a residual Cartesianism, we were delivered from schizophrenia. We could then be normal human beings, totally sane, and yet do physics. So that is one thing that came out of this work, namely the clear ontological discernment between two ontological planes, the corporeal plane which we perceive, which defines the world in which we find ourselves, and then this physical universe, which you can say is half discovered, half constructed by the physicist. That's another world.
While it was Wolfgang's return to his Catholic roots that launched his writing career,
ironically, it was a Muslim, a traditionalist, a perennialist, indeed a direct descendant of the Prophet Muhammad, who turned out to be his early champion, publishing his works repeatedly over the years in the journal Sophia. We went to Washington to sit down with this great philosopher and champion of Wolfgang Smith, Dr. Syed Hossein Nasr.
Wolfgang has told me so many stories about Syed Hossein Nasr, who championed Wolfgang's work for decades on the questions that have perplexed humanity for the past century, since the discovery of quantum physics.
Allow me to begin this discourse in God's name, because it's God who made Wolfgang Smith and I meet. So we meet in him. I first ran across an essay of his. I began looking him up on the books of his which were available. I began to read, and after reading a few pages, was very impressed with the combination of depth and spiritual awareness to be found in these writings. And so through the writings, we clicked, as the Americans would say. We became friends, and we began to correspond. I've never met him, even now, but we've spoken many times on the telephone, exchanged many letters, many ideas.
One of the things that I must thank you for is that when Stephen Hawking published his very famous book in 2011, The Grand Design, you immediately sensed that this was a sign, that the appearance of this work was something that could not go unanswered. And I have to personally thank you for that, because that is how I first found out about Wolfgang Smith. I saw that essay. Now, you're one of the most famous philosophers in the world. You have probably got a Rolodex with the best names and numbers in the world, but yet you picked Wolfgang to reach out to. I wonder if you could tell us what it was that led you to sort of assign this task to Wolfgang Smith.
Like Wolfgang, I began to study the sciences. I studied physics and mathematics at MIT, and I was a very gifted student in physics. I was number one in my class. But by the second year, when I was a sophomore, I read right through physics. The great Greek philosopher Parmenides says that I'm a physikos in Greek. In my mind, without realizing, as an 18, 19-year-old young man, that's what I wanted to be. I wanted to be that kind of physicos, not this kind of physicist. But I stuck it out. I got my degree. I went to Harvard. I also studied geology and physics, and then philosophy, history of science, because I wanted to have this background. I wanted to be able to criticize modern science on the basis of the traditional science and cosmologies and worldviews and philosophies that I discovered through very wide reading. And I know enough about modern science not to be rolled over by people say, oh, you people don't know what you're talking about, and so on and so on. I'd studied all the way up to quantum mechanics and very advanced mathematics, and I was not going to be fooled. I was looking for a voice who I thought would be able to revive the role that a man who knows science well can play in reviving the philosophical and metaphysical aspects of knowledge and critiquing the monopolistic tendencies of modern science.
In addition to Syed Hossein Nasr's influence in introducing Wolfgang Smith's work into traditionalist circles throughout the world, Olavo de Carvalho, a Brazilian thinker, has recently introduced Wolfgang's work into circles including physics professors and students interested in Smith's resolution of the quantum enigma.
A few hours south of Washington, D.C., we visited Olavo de Carvalho in his home in the beautiful Virginia woods.
We are so very pleased to welcome Professor Olavo de Carvalho, a man who has made original contributions to the restitution of authentic philosophy, and a man who has had the remarkable achievement to launch and found and sustain an actual school of philosophy, which seems to be attracting thousands upon thousands of young people in Brazil who are answering the clarion call at this critical moment in history. How did you put this together? How did you make this happen?
My real interest was the education of young people, not children. I am not gifted to educate children, but young people from, let's say, 15 to 25 years. And this is my dream, to educate these people to the tasks of high culture, because this did not exist anymore in Brazil. The high culture had been totally destroyed. I started this internet course, and now I have 5,000 students. There was never a course of philosophy that was so big in the whole history of the world. Plato had not 5,000 students, and Socrates and Aristotle, nobody.
I can tell you that when we launched the Philosophia Initiative website for Wolfgang's work, we noticed suddenly that, like, huge percentages of the visits that we were getting and very large numbers of the really best comments that we would get during the philosophical discussion were coming from Brazil. And this was like, that's a level. That's a level. It is possible to take unique historical circumstances and undertake an outreach to young minds, to young people, and give them the opportunity to encounter the work of Dr. Wolfgang Smith, the work of men like Olavo de Carvalho, men like Syed Hossein Nasser, and give these young people a chance to reconnect back to the entire panorama of the wisdom of humanity.
Well, the first time I heard the name of Professor Smith was in 1986 at Dr. Rama Kumaraswamy's house. He showed me the book, and I read it in 2 days. I got absolutely fascinated because it said everything I want someone to say. It was a complete refoundation of Western science in new bases. Pulling again, giving new life to very important truths that had been forgotten for 5 or 6 centuries.
Today, the only way left is upwards. The resolution of the quantum enigma by Wolfgang Smith commences with what might be termed the rediscovery of the corporeal world, the world of perception, where the grass really is green. But once we have broken free from the Cartesian bifurcation, we're left once again with a dichotomy, with 2 domains. The corporeal world, in which we live and move and have our being, and the physical universe, the world as conceived by the physicist. It turns out that there exists one and only one function, S, from the corporeal to the physical domain, which can serve as a bridge, one which is in fact in constant use, since otherwise no science of the physical would be possible. S is the function which to every corporeal object X assigns the physical object Sx, which is none other than the corporeal object X as conceived by the physicist.
Sx represents the quantitative side of X to the exclusion of all else. What has been jettisoned, to put it in Aristotelian and Thomistic terms, are precisely the qualitative attributes of X and its substantial form.
Brilliantly, Wolfgang Smith separates the corporeal world from the physical world. Establishes great contribution to show that the corporeal world, first of all, is not simply based on, you might say, or the reduction of the physical world. It's another set of being. That's a very, very important contribution, the ontological jump.
One can aggregate as many potentiae as one pleases. They of themselves cannot bring us across the bridge from the realm of potential to the realm of act, from the physical or quantum realm to the corporeal universe.
What actually stands at issue is a fundamental and hitherto unrecognized mode of causation, vertical causation, which in fact is more basic than physical causality.
It thus becomes apparent that the resolution of the measurement problem, the so-called phenomenon of state vector collapse, requires two new conceptions.
First, the idea of a corporeal as distinguished from a physical entity, and second, a distinction between two fundamental modes of causality, what Smith terms horizontal and vertical causality, the first of which operates in time by way of a sequence of events, and the second of which operates instantaneously, as if from above. No one on either side of the Copenhagen debate seems to have realized that the role of quantum particles is not to bestow, but to receive being.
Meanwhile, unrecognized though the fact may be, vertical causation has also made its appearance in what is arguably the most profound discovery of physics, what has come to be known as Bell's theorem. What John Stuart Bell discovered, in flat contradiction to what physicists had believed since the days of Newton, is the existence and quasi-ubiquity of so-called non-local correlations, which take place instantaneously without a transfer of energy.
To convey the gist of what stands at issue, let us consider a pair of what are termed polarization-correlated photons, P and Q. This means that if one measures the polarization of one of these photons, the polarization of the other is thereby determined as well. Now, consider an experiment in which the photons P and Q are sent off in opposite directions, as far as one might please, to stations A and B, respectively. And suppose that the polarization of P is measured at A. Inasmuch as the photons are polarization correlated, this measurement will instantly determine the polarization not only of P, but of Q as well. The effect of this measurement on Q cannot, therefore, be ascribed to any field-based transmission.
Now, what confronts us in the phenomenon of non-locality is none other than what we have termed vertical causation. The deeper and more extensively one probes into the secret workings of nature, the more the ubiquity of vertical causation will come to light. It emerges that the notion of a mechanistic universe, which has bedeviled our civilization since the days of Descartes and Newton, has now been irrevocably disproved.
Everything we know about nature is in accord with the idea that the fundamental process in nature lies outside space-time, but generates events that can be located in space-time.
The existence of vertical causation was confirmed in 1998 by a mathematician named William Dembski, whose story we need to tell next.
In 1998, this hitherto unknown mathematician startled the erudite world with a theorem that has revolutionized our scientific understanding of causality.
Dembski introduced an idea which proves to be crucial: the notion of specified information. Whereas every event produces information, Dembski sharpens this concept drastically by two innovations. First, the notion of a detachable target, followed by the imposition of a probability bound large enough to exclude accidental hits. The information generated by events meeting these two conditions is termed complex specified information. In a word, CSI is information generated by an event which, like an arrow striking a bullseye, meets a highly restrictive condition.
With these basic definitions in place, William Dembski was able to prove one of the most remarkable theorems in the history of mathematics, namely, that no combination of natural causes, random, deterministic, or stochastic, can produce CSI.
Neither a book, nor even a simple artifact, let alone the genome of an organism, can be produced by horizontal causes alone.
The vertical causation necessary to resolve the quantum enigma proves to be ubiquitous. The discovery of vertical causation as operative throughout nature, from the measurement of a quantum system to biogenesis to the making of a water pot, has de jure invalidated the post-Galilean worldview and brought to an end the period known as the Enlightenment.
The scientific war on vertical causality has in fact assumed two corresponding forms, epitomized respectively by Darwinian biology and Einsteinian physics.
The Darwinist hypothesis has actually been rigorously disproved on the strength of Dembski's design inference theorem, which establishes once and for all that the tons of complex specified information, or CSI, contained in the genome of even the simplest living organism cannot be generated by horizontal modes of causality, period. Darwinism, thus, as a scientific theory, came to an end in the fateful year 1998, when William Dembski established his spectacular result. The fact that the scientific establishment at large has reacted to this fact by obfuscating the issue, and that a judge even in a court of law has in effect ruled against Dembski's theorem, all this, thought-provoking as it may be in its own right, constitutes basically a sociological phenomenon beyond the pale of our present focus. We contend next that Einsteinian physics wars against cosmic vertical causality.
Einstein, in his famous 1905 paper introducing special relativity, mentioned the, quote, unsuccessful attempts to detect any motion of the Earth relative to the light medium, unquote. Only a few years before, the famous Michelson-Morley experiment had attempted to measure the orbital motion of the Earth around the Sun. And to the great perplexity of the physics community, had failed to detect any such motion. Because of this failure, the equations of physics were rewritten to explain this apparent lack of orbital motion of the Earth.
What motivated Einstein evidently was the conviction that the Earth, or equivalently reference frames stationary with respect to the Earth, could have no preferential status. That, in other words, there can be no design or architecture on a cosmic scale. His is a radically egalitarian physics, which equalizes not only reference frames, but even the fundamental cosmic bounds of space and time by combining them into an abstract, mathematically conceived space-time.
In 2014, I was involved in the release of a film entitled The Principle, which dealt with the fundamental assumption of standard cosmology, the so-called Copernican principle, which simply states that we are in no special or central location with regard to the large-scale structure of the cosmos. The principle deals with the stunning recent observational evidence to the contrary. And of all the benefits which have accrued to me from making that film, the greatest, I think, is that it is the means by which I met Wolfgang Smith. I interviewed him for the very first time, and he had some very interesting things to say about the principle.
Your film comes into this moment of history and captures it in a masterful way. You have, first of all, the documentary evidence. You can see the microwave background. Colors show the different temperature regions, the so-called axis of evil. Well, the fact that this microwave background turns out to have a well-defined axis negates the fundamental assumption on which all of our astrophysics has been based for the last 60 or more years, number one. And number two, the fact that this axis lines up with the ecliptic of our solar system is almost an insult following injury. It takes us right back to pre-Galilean cosmology. Our solar system is central. So this has enormous significance. I mean, you could not possibly overstate the scientific and philosophical and cultural impact of this discovery.
There is an absoluteness, and Wolfgang is completely right about this, absoluteness about direction of space, about our experience of space from the Earth, of dimensions of space. And this is to the great really credit of Wolfgang Smith, who brought this out so clearly. The vertical always symbolizes transcendence. You know, even ordinary people who are atheists, and they're happy, they go like this. They don't go like this. When you're happy, you never go like this. You look to heaven.
That's so beautiful.
Even if you think you're an atheist.
That's so
it's inbred in our nature. It's needed in our nature.
To be sure, the geocentrist outlook commends itself to simple and untutored minds, as we have been reminded often enough, and moreover, accords with the understanding of sages and saints. What is new, that has sent shockwaves through the scientific establishment, is that empirical findings in the domain of astrophysics have begun irrevocably to side with the aforesaid simpletons.
The so-called Copernican principle, brought into play at a later date to found the Einsteinian astrophysics, proves to have been the driving force behind relativistic physics from its inception. The question remains whether it is compatible with the most spectacularly accurate physics ever conceived by man, namely quantum physics. Now, it happens that this question has been investigated by the brightest theoreticians for well over half a century. An enterprise, moreover, which has engendered the most extravagant displays of mathematical acrobatics the world has ever seen, including 11-dimensional spaces, which fold into the ambience we normally behold in ways too subtle for ordinary minds to grasp, but all to no avail. And by now, at last, the verdict appears to be in. Do what you will, Einsteinian physics and quantum theory cannot coexist. As physicist Michio Kaku explained in The Principle,
the theory of the big is relativity. It gives us black holes and big bangs, the things we can see with the naked eye in outer space. Then there's the quantum theory, the theory of the atom. Now, the juncture between the two, that's when all bets fail. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
And so at last we face the conclusion that the most famous and lavishly touted scientific theory in modern history turns out to be untenable. It is important to note that in this regard, quantum theory constitutes the polar opposite of Einsteinian physics. For it is clear that the physics of Max Planck and Werner Heisenberg has imposed itself upon the scientific community not on the strength of ideological premises, but on the basis of incontrovertible findings that transgress the assumptions of Newtonian physics. It should surprise no one, therefore, that in the end it is quantum theory that prevails. It is nature, after all, that has the last word.
Reality must take precedence over public relations, for nature cannot be fooled.
I've told you how I met Wolfgang Smith. Now I suppose it's time to tell you how he has changed my life. When I first met Wolfgang, I felt like I was coming into contact with a world that has passed away. A man who is equally at home in the ancient schools of philosophy and the quandaries of quantum physics. And it's true. Wolfgang may very well be one of the last representatives of an earlier time when physicists still felt themselves limited by their ability to experimentally test their theories with the intention of possibly falsifying them. A long step from current multiverse theories. We do live at a moment where one great arc of history is closing and something entirely different shall certainly arise. And lastly, my friend, Wolfgang Smith, has taught me to never, ever forget that the cosmos and everything in it, at every second, is being both brought into existence and held in existence by something incomparably higher than those aspects of reality which can be reduced to an equation.
I love Professor Wolfgang. I love him. I love him. This is the least I can say. I believe he's a great heart. He's very sincere, very honest, and he is telling you the truth the best he can. A man like this, you can find one or two in a century. Please listen to him, because your life depends on it. The life of this nation depends on it.
The realization that nature is not, after all, a dull affair, soundless, scentless, colorless, merely the hurrying of material endlessly, meaninglessly. This alone restores to us in principle the perennial wonder of the world, from the song of birds and the murmur of trees to the silent call of things that enter not into the minds of men.
We should rejoice and be profoundly grateful that the world proves in fact to be vastly richer and incomparably more sublime than the pundits of the flatland had taught us to believe.
And that, finally, It points beyond itself to something greater still.
Above the entrance to the Platonic Academy at Athens, we are told, was an inscription which read, "Let no one ignorant of geometry enter here." The great project to reduce the world to what can be measured and operated upon by the instruments and procedures of physical science is reaching its end. And in reaching its end, finds itself confronted by the ancient wisdom of humanity, which wisdom modernity continues to be perfectly persuaded has been banished forever to a pre-scientific age of myth and superstition. As it turns out, not so much. The cosmos transcends the domain of physics and cannot be reduced to it. The disintegrating dream of a theory of everything might not be quite yet at the nightmare stage for the theoretical physicists, but it is not that far off either. The notion of an integral cosmos, read as an icon, as a sign, as an up, furnishes the key by which we return from an infinite multiverse concerning which we can never know a single true thing. We return at last to the real world.
The builders keep on building. The tearers down keep tearing down. The killers keep on killing. Dead keep coming around. In the words of Albert Einstein, there is no solid ground to build on, but the builders keep on building, looking down, 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 one way up, one way up, way up, one way up, one way up, way up, one way up, one way up, way up, one way up, one way up, way up. Of all the superstitions to arise beneath the sun, today the theoreticians hold the very greatest one. There must be an equation, it someday will be found, to calculate the whole world up now. Once we write it down, 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 down. One way up, one way up, way up, one way up, one way up, way up, one way up, one way up, way up, one way up, one way up, way up. The great convened at Harvard, expecting to be blessed. Back when Solzhenitsyn made his passage to the West. But when they heard his warning, oh, their smiles were turned to frowns. He said there's only one way up now. You're still going down, 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 down. One way